Hello, hello, hello. Okay. So, good morning, everybody. I hope you're still fine after yesterday. So, today we're going to talk about Istio. How many of you have been on yesterday's talk about Istio? That's great. In this case, I can skip some of the parts. So, let's go. My name is Ziółkowski, sorry. I keep used to living abroad, so I have to say Ziółkowski because no one has idea what Ziółkowski means, how to pronounce it. So my name is Dawid Ziółkowski. I work for a company called Container Solutions, a consultancy. We have a couple of offices, and one is here in Warsaw. So if you're like dreaming about Kubernetes at least 2 times per week, let's say, then feel free to apply. But today we're going to talk about Istio. And we're going to talk about Istio in a way for you to understand it, let's say. Because the problem with Istio is that it's very complex, actually. Like, to understand it fully, it's pretty complex. It's actually kind of like Kubernetes. So it's easy, to start with Kubernetes, just to deploy it, deploy some pods, but there's so many things out there yet. So just understanding how to start with Istio is usually not enough, because installation is easy, but what to do actually next. So I'll try to give you a lot of background, a lot of theory for you to understand really how the Istio works, so we can actually do something interesting with it. So, in order to do that, we need to talk about something else actually than Istio first. We need to talk about ServiceMesh first. We need to talk about Istio from the beginning, so from ServiceMesh, from the really beginning. So let's go back in time a bit. So when the dinosaurs were still walking on the earth, we had a situation that in order to deploy anything, like, website, application, whatever, we had a server, right? And that's it. We just have a server. We had to take care kind of everything. We need to take care where to put it, how to connect it, how to install operating system on it, then install something that our application needs, like, if it was Java application, then you need to install Java and so on and so on. So we had to take care about really everything. And then the problem comes when you need to upgrade it or do something, because then like the whole process probably you need to do again. So that wasn't a perfect solution. Fortunately, some smart people invented something called virtual machines. So that changed a bit because, we still had that physical server. In many cases, we still had to take care of it ourselves. Not necessarily, but still. But then we kind of stripped down the physical server, and we shifted our focus onto the virtual machines, right? So that was a bit easier because you could just template. You could have template of virtual machine. You could even have template with everything inside. So then you just spin up the template. It still took ages, but it was better. Fortunately, again, someone came to thinking, okay, what we can strip down more, right? So if you think about it, then of course, what you have here in that virtual machine, and then it's like 60% it's still operating system, and 40% is your application, right? So here you have operating system, here you have operating system, here you have operating system. You don't care of any of these. And anyway, you have operating system here anyway, so who cares? So people thought, okay, let's move this thing out somehow. Not that button, sorry. And that's how containers were born. So it's no longer dinosaur, it's whale now. So the thing was, we still have that physical server, which we don't care about anymore ourselves. And then we have containers. So the idea behind the containers, right? It's just we have only application inside, right? We don't care anymore about operating system. We don't care about anything except our application, right? And if you are good on the containers, then you have even your application split down into microservices, of course, right? So each container is really, really small. And yeah, that's the perfect situation, right? Because we get rid of the operating system. We have only our application inside. So yeah, we can't move out anything more, right? Because it's our application. Well, not really. If you think about it, if you think what's inside that container actually, then yeah, it's application code. But what's that code? If you look closely, then you realize that there is still some things you can get rid of. Because let's imagine that this container is, I don't know, front end, this container is back end, right? So we have some JavaScript probably here, some, I don't know, Python or whatever here. And yeah, imagine that client comes to your website, he clicks something, I don't know, register, buy, submit, whatever, and then we send a post or GET request to our backend, right? Now, in JavaScript, for example, to send the GET request or POST request or HTTP request, it's just 1 or 2, 3 lines of code, right? And that's what you care about, right? That's your business logic, to send some request that does something. But what you actually need to write is much more, because you need to write, first of all, you need to somehow take care, first, you need to somehow connect to that backend. Maybe you need to first check if the backend is alive. Then you send that request, but what happens if you get 500 back, or what happens if you get something you're supposed to? So you need to write still the code which does the retry, or you need to still write the code which does a lot of stuff around that GET request, right? So that's where ServiceMesh comes into the idea. The idea behind ServiceMesh is to get rid of everything I just explained, so everything around what we care about. To strip down all the code you have in your microservices which does not do business logic itself, but all of those stuff around, so those retries, that everything. And that's a huge deal, because imagine this example. We have that GET with a bunch of more code here. We have similar code here. We have similar code in each of these. And since we are running microservices, then each container can be written in different languages, in different language, right? So if it would be all the same language, then maybe it would be easier because you can just reuse the same library or something on the same code. But since we have a lot of different languages here, then to do that simple thing like retry, you have to write it multiple times differently, right? Because retry in JavaScript will be different than retry in Python and so on and so on. So you'll still write a lot of code, which is not your primary goal, right? It's not your business logic. And the difference with ServiceMesh is that you do it once. So if you want to do retry, you can just add retry equals, I don't know, 3 times to YAML file, and that's being applied to all microservices, no matter what languages they're written in. So that's the main selling point of ServiceMesh. So you can strip down all the code from your microservice, put it to ServiceMesh, where you just define it once. And that brings, of course, advantages, because yeah, as a developer, yeah, you have less work, let's say. As a manager, you get your features faster, because if you ask your team to develop, I don't know, 5 new features, they can do it faster because they need to write less code, right? And at the end, it also prevents you from the situations that, okay, we need to do that feature fast, so we will do that retries, and all of which we're supposed to do at the beginning later, right? It's very easy to do it with ServiceMesh, so you kind of don't lose that. You don't create those issues which you're supposed to fix later, but you don't. So that about ServiceMesh, and now let's go back to Istio. So that's the official definition of Istio. That's how Istio says what it is. Basically, Istio allows you to create ServiceMesh. So you need to understand also that ServiceMesh is just the idea, just the idea how to do stuff, and Istio is one of the tools which allows you to implement that idea. So it's not like ServiceMesh equals Istio. It's more like, yeah, it's more like Kubernetes is container orchestrator, Mesos is container orchestrator, right? It's kind of the same thing. So that's boring. Let's move on. That's how Istio works. I'm not going to go into the details because it was yesterday, but basically just to remind you, we have basically a few components of Istio. So if you install Istio, then it deploys few pods in Istio system namespace. Then we have our microservices. Then we have that famous Sidecar, Istio Sidecar proxy thingy. which is the most important for us at the moment. So yeah, it's good to understand what of these components all are doing, but in real life you don't even need to know what they are doing, right? Because they are designed to do something for Istio, but if you want to just start with Istio, then you don't need to know. So, what's the Sidecar thingy? So Sidecar, yeah, is Istio man in the middle. It's in the middle between your microservice and the rest of the microservices, or between microservice and the network, let's say. And what it does, it hijacks all the traffics coming to and from your container, and that's why all of the Istio features you can get without changing your application and without even changing your deployment, because it basically hijacks all the traffic, right? So it can manipulate the traffic on its own, like before it comes back to microservice or before it comes to the network. And now, in order to understand how it does it, we need to also come back a bit back. We need to go a bit back. The problem is we need to understand how it does it, and we need to understand what's the container and what's Kubernetes pod in order to understand how Sidecar works. And there is a thing that there is no such thing as container from Linux kernel perspective. That's important. So in Linux kernel, the kernel doesn't know what container is. There's no such thing like give me a container or something like that. What is though is namespace isolations. So in order to create Docker container, let's say, you need to instruct Linux kernel to apply namespace, few namespace isolations, isolation namespace. You have few namespaces in Linux kernel which can isolate some things. So network namespace can isolate network. IPC namespace can isolate inter-process communication. User namespace can isolate users, and so on and so on. So we have some, if you have some Linux process running on Linux hosts, right? Yeah, let's say Nginx. So that process, if it would be running normally on Linux server, and if it's running inside a Docker container, from Linux kernel, it's the same. It's exactly the same process. The only difference is that the kernel applies like packages into those namespaces. And then, if you apply all of the namespaces that Linux kernel gives you, then you get a container. Okay? And now, so if we have two Docker containers, then this container can't see users of this container because they are in different user namespace, user namespace, yeah. Then this container, this process also can't see the users of underlying host system because it's also isolated, right? So it's just the form of isolation. For the same reason, if you bound that Nginx to port 80, if it's going to listen on port 80, this Nginx can also listen in port 80 because they are in different network namespaces. So network is also isolated between them. And that's how pure container works. And now what Kubernetes pod is, that's a bit of a different story. So people used to say that Kubernetes pod is just a way of grouping containers, but it's not the case actually. If that would be the case, then they all would be separated, still separated the same way, then just put something to group them. But what's happened in reality is that they are separated by some namespaces, but they share different namespaces. So it's kind of mix-match. And if you can see, for example, mount namespace is still separated, so this container can have different mounts than that one. But for example, something like network, they share network. And what it means is that these two containers, for them, it looks like they're running on the same machine, for the same virtual machine, let's say. So, yeah, so what it creates is that if we have Nginx here, and if you would have second Nginx here, and if that one binds to port 80, that one couldn't. Because localhost for this container is localhost for this container because they are in the same network namespace. That's how Kubernetes pod works. And what it means is also that if this container applies some IP table rules, like, I don't know, IP tables, drop all, whatever, then the same rule applies to this container as well, because again, they are in the same network namespace. And what it also means is that if we deploy Istio Sidecar here instead of FluentD, and that Istio Sidecar, first thing which it will do will be apply some IP table rules to redirect all the traffic coming to that pod. So it goes first to Istio and then go to Nginx. That's how Istio hijacks all your traffic. Because wherever you apply, whatever IP tables you apply, whatever you do with network in one container, it happens in the second container. Actually, no, it doesn't happen in the container. It happens like for the container, right? So the other container sees the same thing. So that's exactly how that sidecar hijacks all your traffic. That's why you don't need to do any changes in your microservice. You need to instruct your microservice to use Istio, because basically it just hijacks you. If that's clear, then let's talk a bit what that sidecar really is. Basically, that sidecar is just envoy proxy. Just envoy proxy, that's it. So Istio basically uses envoy proxy, and most of the ServiceMesh, Linkerd, Kuma, they also use envoy as the proxy. Basically, it's a pretty good choice, right? Envoy is super has super low overhead. It's layer 7 proxy. That's what's important. We're gonna come back to that later. But important thing also is here this guy. So Envoy has very low performance overhead, and so does Istio. And what very low means is that roughly for every 1,000 requests per second per microservice, you need 0.5 vCPU and 50 megabytes of memory for that sidecar. So it's not a lot. If you would have 100 microservices, then you would need 100 envoys, then you would need extra 5 gigs of memory. But if you have 10, 20, 30, then it's not actually that much. That's for the proxy itself. Then for Istio telemetry, so the Istio component which basically provides you monitoring and observability, you need also 0.6 vCPU per 1,000 mesh-wide requests per second. So it's also not that much. Then Pilot. Pilot is the component of Istio which kind of does most of the stuff, orchestrate a lot of stuff. And that one needs 1 CPU and 1.5 gigabytes of RAM, but that's no matter how many envoys you have. Actually, well, of course there is some upper limit, but it was like 4,000 envoys or something. So in real life, you just need 1 envoy. So we just need, that amount of resources. So it's not much. And then Envoy, of course, will add a bit of the latency to your microservice, since instead of going directly, it needs to first go to Envoy, and maybe Envoy needs to do something with the traffic. So of course, it's give you a little bit more latency, but Istio did tests, and they claim that it's around 6 milliseconds for most of the traffic. So overall, you should performance overhead from Istio. But if you really do, try consider Linkerd, because it's way less overhead, even though that one is not much. All right, so we cover ServiceMesh, we cover roughly Istio, and now, yesterday we saw a lot how you can work with Istio. So just to quickly recap, basically you work with Istio. Istio installs a lot of CRDs, and then you configure all of this with YAML files. So exactly the same way like you do with all the other Kubernetes objects, right? So we quickly skip that. Now, maybe we should start from that one actually, why we need Istio at all. Well, first of all, you get that advantage that since Istio hijacks all the traffic, and then you don't need to rewrite some code inside the microservices. Yeah, that's a huge deal. But even without it, Istio allows you to do some stuff which Kubernetes also already allows you to do, but Kubernetes allows you to do it like very very basic way, very simple way. And Istio is kind of, yeah, it gives you like kind of Kubernetes on steroids, let's say. So it does similar things also, but much better. I know, for example, if you have service for your deployment, right, in Kubernetes service, then it will just, it's just load balancer, logical load balancer, right? But the only thing it can do, it can only send randomly traffic to any container in the pod. And then Istio can do the same, so it can also do the load balancing, but you can configure it in any way possible. We're gonna show that, we're gonna see that later. So yeah, so thinking of Istio is like, it's something on top of Kubernetes, which gives you a lot more than Kubernetes itself, right? Yeah, so to wrap up theory so far, so Istio, so basically what Istio is few components of Istio, so few microservices which run in Istio system namespace, if you install it, of course. Then we have that Sidecar proxy container which attaches to any deployment and which hijacks the traffic, and that's the one who manipulates the traffic. And well, yeah, one of these components of Istio, they are constantly talking to these envoys to configure them. So if you apply some YAML file, then some of the components sees, okay, I need to change something, then it sends new configuration to the envoys, and that's basically how it works. So yeah, everything we configure through YAML because yeah, it gives you a lot of CRDs. And on top of that, we do that all because it gives us more than Kubernetes itself. So, how to start with Istio? If you are convinced, then you need to do not much. So first of all, you need to do platform-specific prerequisites. So the thing is, depending on where your cluster is, if it's on Google, if it's on Amazon, wherever, then you need to go to Istio docs and do something specific from that cluster. I'm not going to tell everything because that's quite a long list. But for example, if you have Kubernetes on Google, so GKE, then you need to go to GKE prerequisites in Istio docs, and that will tell you that you need to execute that one command. And that one command is basically applying few cluster role bindings to allow your user to install Istio. Easy and non-intrusive installation. That's pretty nice because installation of Istio doesn't change anything in your cluster. So you could even install Istio easily on your production cluster because nothing changes. So installation of Istio is just deploying those components of Istio. But before you start injecting the sidecars to your microservices, before you start applying some YAML files, it doesn't do anything. So it's pretty safe to test Istio. And then, yeah, then injecting sidecars. Yes, because we're talking how to start. So we have prerequisites, then we install Istio, then we need to inject sidecar, because again, if you don't, then yeah, Istio doesn't do anything. Injecting sidecars, you can do it either manually or automatically. If you just want to play with Istio, then probably you just want to do it manually just to test stuff. But what you can also do, you can instruct Istio to inject sidecar automatically to anything you deploy. So any deployment you do in a specific namespace. So you can just create new namespace, Istio test, whatever, and instruct Istio to only inject itself into that particular namespace. So it's still safe to test it. And then Istio Gateway. Istio Gateway is a component which replaces Kubernetes ingress. If you really want, you can still keep using your ingress, wherever that ingress is, and it will work fine. You will only lose a lot of observability things which Istio gives you out of the box. We didn't talk about this yet, but probably you remember from yesterday talks that Istio also deploy Prometheus, Grafana, a lot of stuff. So out of the box, you have pretty nice monitoring system. And if you keep using your Kubernetes ingress and you don't use Istio Gateway, then you won't see much metrics from that one. But if you switch to Ingress Gateway, you can see everything, and you can also apply some rules to the gateway the same way like you do for the sidecars. So it's definitely wise to switch to gateway, Istio gateway, instead of keep using your Kubernetes ingress. All right, so assuming we want to install it, installation is pretty simple. There are 3 ways to do it. First, and recommended, is by Istio control. Istio control is a binary which you get from Istio simply by executing the curl command. What this does, well, for any installation except operator, for any installation of Istio, you need to first download Istio, of course. And if you download that package, then you get that Istio control binary, then you get some examples, then you get quite a lot of stuff which you need for installing Istio. So if you download Istio, then you just need to execute Istio control manifest apply, and boom, Istio is installed. It takes, I don't know, 5-10 seconds. It applies, it creates all of these 7 custom resource definitions for Istio. It applies all of these microservices in Istio system namespace, and that's it. It doesn't do much more until you apply some configuration. Also, if you do just this, Istio control manifest apply, then you will install Istio in a not most basic, but in a default way, because there are few ways of installing Istio. Let's say you can do Istio control manifest list minus list, I think, and then you will get a bunch of other options. So we can do also minimal installation. You can do installation with MTLS enabled by default. So there's few of them. And that one gives you the default installation. Second way is through Helm. It's still fine, but it will be deprecated in the future. So yeah, if you just want to test it, if you're fine with Helm, then you feel free to use that method as well. But keep in mind that it's going to be deprecated. And third method, which is experimental, is through Istio operator. But that one was just introduced with Istio 1.14, which was released like 2 or 3 weeks ago. So it's just still alpha. So just, I think, keep with Istio control. So assuming that we installed Istio already, then what we can do, what we need to do, because if we don't do anything, then it won't do anything. First thing we need to do, we need to decide how we want to inject these sidecars into our services. And as I said earlier, you can do it manually, automatically. And basically, the difference is, either you have to do it manually yourself, of course, or you do it automatically. Normally, I think most of the cases I've seen, you just use automatic injection. Even if you just want to test Istio, then just apply auto injection on one specific namespace. But if you really are curious or something, then you can just do manual injection. And injection of the sidecar. It also means again that you don't need to change anything in your Kubernetes deployment. So your YAML file can just stay as it was. You don't need to change anything because that injection of the Istio, it happens kind of separately. You don't need to add Istio yourself to YAML file, right? What injection actually do is it takes your YAML file, which you send to Kubernetes API to deploy something. It takes it, it changes, so it adds some Istio components, and then it sends it back to Kubernetes before it's actually sent to the API. Yeah. So again, you don't need to care yourself about anything. So then, assuming that we have Istio installed, we decided to enable automatic injection in some namespace. Then what happens? If we would deploy something now, so we have Istio installed, we have sidecar injection enabled. If we would deploy something now, then our microservices will pop up, and they would have Istio sidecar injected. But it wouldn't do much yet, because we didn't instruct Istio to do anything with the traffic. So it would hijack all the traffic, but it wouldn't change anything to it. So in theory, still nothing changes. When it changes, when you apply some configuration. And these are the 4 most commonly used custom resource definition in Istio. For those who don't know, custom resource definition is if you do kubectl get something, then you have pods, nodes, deployments, wherever. And custom resource definitions are these which are installed by some other components, so which are not by default in Kubernetes. So if you don't have Istio installed, if you would do kubectl get virtual service, then Kubernetes wouldn't know what it is. But if you install Istio, it installs those custom resource definition, and then if you would do kubectl get virtual service, then it would know what it is. So these 4 are the most important. Virtual service is something that you does most of the stuff, most of the features. So most of the features you can get from Istio, you would probably add to virtual service definition, and then you need 1 virtual service per deployment, per service, per Kubernetes service. So it acts like on top of Kubernetes service. It doesn't replace Kubernetes service, you just apply it on top of that. Then gateway replaces ingress, so that one probably you just deploy it once to have a gateway, or maybe twice if you want some gateway for testing or something, but normally you would just deploy gateway once and you have that always. Destination rule is used to instruct Istio how to route the traffic from service to containers. So you have gateway, the traffic coming from internet goes to gateway, then it hits virtual service sends it to Kubernetes service, then from Kubernetes service it goes through destination rule, and then it goes to the container. The difference between these 2 is that if you have Kubernetes pod, if you have, let's say, few versions of your microservice, let's say you have UI, and you have 3 versions. One UI has, I don't know, black background, the other has white background, the other has something else. Then you would use destination rule to route the traffic, to do something with the traffic between these 2. So destination rule is used to group the same application in multiple versions, while virtual service is just to route to the service itself. And then service entry. Service entry was really important, but it's not anymore. It was important because back in the past, Istio by default blocked all the outgoing traffic to the internet. So if you install Istio, then you wouldn't be able to connect from any microservice connect to the internet. So any outgoing traffic was blocked basically. And service entry was used to allow the traffic. It's not needed anymore. Well, it's not needed anymore by default because now, since I don't remember which one, 1.11 or 1.12, they changed. So now in recent versions of Istio, by default, outgoing traffic is allowed. So you don't need to use this anymore. But if you are, if you want to secure your cluster and you want to disable outgoing traffic by default again, then you need to whitelist something with service entry. Yeah, and these are the four mainly used. Yeah, actually 3 because you don't need service entry anymore. And there are quite a lot. Yeah, Istio installs 27 of these, but you would mainly use these 3. So yeah, we saw that yesterday. So let's quickly skip. We saw that yesterday too. Yep. So now, Canary deployments. Yep. Very quickly because we saw that yesterday as well. Because Envoy. Oh yeah, now we're coming back to the Envoy because Envoy. Because Envoy is no, not yet. Sorry, not yet. But basically, Canary deployments with Istio, you can instruct Istio to send certain % of the traffic. I think we saw it even here. no, we didn't. You can send certain percent of the traffic to your microservices, so we can do Canary deployments with Istio very easily, because you can instruct it that at some point, if we want to roll out new version, we roll out new version and we instruct Istio to only send 10% of the traffic to that service. Then we check if everything is fine. If everything is fine, then we instruct Istio again to send 100%. And that's Canary deployments, right? Pretty easy to do with Istio, something you can't do with Kubernetes. So from that point, assuming that we have Istio installed and we understand how Istio works, from that point, what you would do is, sorry, just check the time. Yeah. From that point, you would just go to Istio documentation and check all the things it can do, because it can do really, really a lot of stuff. Like you heard already about retries, you heard about fault injection and stuff, but this is really like tip of the iceberg from what Istio can do. It's definitely not enough. 45 minutes is not enough to give you all the stuff which Istio can do. But if you understand how it works, how it hijacks the traffic, why it does it, then you should be able now to go to Istio docs and pick any feature you are interested in and just apply it. Most of them, again, most of them are just applied with in YAML files, and actually even more, most of them are applied in one specific file, which is a virtual service. So it's also pretty easy. Let's say, fault injection. You just need to add these few lines of code to your existing YAML files. So assuming you deployed Istio, you moved your microservice to Istio, which means you created virtual service definitions for each of these. Then you can just reuse the same YAML files, just add something to it, remove something to it. By the way, fault injection is pretty nice. When I first saw fault injection feature of Istio, I was like, interesting, but why on earth would you like inject issues to your own microservice? I mean, didn't took long, of course, to realize that it's for tests. And when I realized, then it actually makes a lot of sense. Because you can test your microservices with Istio, not with your clients. And that's important, especially if you moved from monolith to microservices, because then you can inject faults, you can inject some 500s or 400s or whatever to some of your microservices and check if your website is still running. Because what often happens is that while moving from monolith to microservices, if one of the components fails, everything should still work fine, and maybe it does. But if some different component fails, maybe your whole website is down because that was some kind of crucial component, and different microservices don't know what to do when that one is down, but they should. So by doing this to random microservices, you can see if your microservice, your application is designed well in microservices, if it can deal well with the issues. And actually, speaking about retries, so yeah, you know already that Istio can do retry. So if you send some call from one microservice to the other and the other replies with 500 or whatever, then Istio itself can do retry that call. Because actually it happens quite often, maybe not quite often, but it happens that sometimes you just have some network issue for a second. One call failed, but all the rest are fine. So if you do simple retries, I don't know, 2, maybe max 3 times, then you already like covered with some of the networking issues. But then, what you can do, you can instruct Istio to inject 500s to, for example, 10% of the traffic, and at the same time, you can instruct Istio to do retries. So you can fix the issue. You can fix with Istio the issue which you created with Istio, if you want to have one. Yep, I think we have 2 minutes for quick demo. Okay, so I have a fresh Kubernetes cluster deployed on GKE. So since I deployed on GKE, I had to go to Istio docs to check what needs to happen on GKE for Istio to work. And again, that was some cluster level bindings to allow me to install it. I installed Istio already just to save time, product page, and so on and so on. But if I deploy it in the namespace, which is enabled to have Istio injection, then you will see that each of these microservices has now two containers inside, because in every deployment, Istio injected the sidecar. And that sidecar, again, it spinned up, it executed some IP table rules to hijack all the traffic, and now everything coming to and from any of these microservices is going through Istio. So if they are running, then we can deploy gateway to be able to access that services. And if we are lucky, then it should work. So we check what the IP address got assigned. Oh, the same. All right, so the application is now running, and now, if we refresh that page over and over, you will see that the stars in the reviews, they change. So currently, it's random. So every time I refresh, the request is sent to one of 3 versions of review microservice. So it's round robin right now. Now, since Istio is taking care of the traffic, I can first apply destination rules, which instruct Istio, tells basically Istio that I have 3 versions of my microservices, and I want you to know about it. So whenever I do some magic with the traffic, you need to know what I'm referring to. So if we check out that file, you will see basically that the destination rule is just mapping. It just tells Istio that if I tell you send the traffic to subset v1, then it means I want you to send the traffic to containers which has a label version equals v1, right? So now, since Istio already knows about it, then we can do something with the traffic. If we deploy virtual service, if we change the virtual service, now every time I refresh, I got 50-50% between red stars and no stars. And that was done by the file which basically tells this: send 50% to subset v1, send 50% to subset v3. Simple as that. But last thing I want to show you. Now, if I log into that website, I still have exactly the same behavior, right? So 50-50 no stars. Yeah, it's like 50-50 like on hundreds, but it's 50-50. Yeah, so if I log out, yeah, still the same. But now, since Envoy is layer 7, then it means it understands HTTP traffic. So it can do something based on the header, on cookies, or whatever. So if we see what we want to do now, we tell Istio this: match the traffic, which has HTTP header called end user, and if that key has a value of JSON, then send the traffic to subset v1, otherwise send to v3. Right? So if we deploy this now, then what happens is I'm not logged in, I'm not, then all my calls going to red stars. And if I log in, then all my calls going to black stars. Right? So that's pretty much about Istio. You install it, you create a bunch of YAML files, and then you just go to documentation, you check the feature you are interested in, and just add to the YAML file, right? Thank you.